Langchain together chat models. Description: Langchain together chat models allow you to chain together multiple chat models in a sequence, enabling more complex and nuanced interactions with users. This can be especially useful for tasks that require multiple steps, different expertise, or a combination of factual information and creative content. Inputs. Input 1: user input, textual query or prompt provided by the user. Input 2: context, prior conversation history or relevant information for the chat model to consider. Outputs. Output 1: response, the generated response from the chat model based on the input and context. Output 2: context update, the updated context that incorporates the user input and response, for use in subsequent turns of the conversation. Steps. Step 1: input processing, the user input is received and processed by the Langchain together framework. Step 2: model selection, the framework selects the appropriate chat models based on the input and the defined chain configuration. Step 3: model execution, the selected chat models are executed sequentially, with each model receiving the output of the previous one as input. Step 4: response generation, the final output of the chain is assembled and returned to the user. Metrics. Metric 1: response quality, this evaluates the accuracy, relevance, and coherence of the generated responses. Metric 2: conversation flow, this assesses the smoothness and naturalness of the conversation, ensuring a seamless user experience. Visualization plots. Visualization plot 1: conversation history, this plot displays the flow of the conversation, showcasing user inputs and model responses over time. Visualization plot 2: model selection, this plot visualizes the model selection process, highlighting the models chosen for each step in the chain. Fine-tune parameters. Parameter 1: model weights, the weights associated with each chat model in the chain can be fine-tuned to adjust the relative importance of different models. Parameter 2: chain order, the order of the models in the chain can be adjusted to optimize the flow of information and ensure the most relevant model is used for each step. Uncertainty methods. Uncertainty method 1: confidence scores, some chat models can provide confidence scores for their generated responses, allowing users to gauge the reliability of the information provided. Uncertainty method 2: model ensemble, using multiple models for the same task and combining their outputs can reduce uncertainty and improve response quality. Challenges and fixes. Challenge 1: model inconsistency, different chat models may have different biases or strengths, leading to inconsistencies in responses across the chain. Sample use case that resulted in challenge 1: a chain might use one model for factual information and another for creative writing, but their styles or interpretations might clash. Fixes to challenge 1: carefully selecting models with compatible styles and biases, adding explicit instructions or constraints to guide the models toward a consistent response, using model ensembles to mitigate the influence of any single model's inconsistencies. Challenge 2: chain complexity, creating complex chains with many models can be challenging to manage and debug. Sample use case that resulted in challenge 2: a chain with multiple models and complex logic might be difficult to understand and maintain. Fixes to challenge 2: using clear and modular chain definitions for easier understanding, employing tools for visualizing chain structures to aid in debugging and maintenance, employing techniques like unit testing to ensure the chain operates as expected. Langchain together embeddings. Together embeddings. Description: together embeddings is a Langchain component that allows you to combine multiple embedding models into a single embedding. potentially improving the quality of your embeddings and making your models more robust. Inputs. Input 1, a list of text inputs, each of which will be embedded by the different embedding models. Input 2, a list of embedding models, each of which will be used to generate an embedding for the input text. Outputs. Output 1, a list of embeddings, where each embedding is the result of combining the embeddings from the different embedding models. Steps. Step 1, for each text input, the component iterates through the list of embedding models and generates an embedding for the input text using each model. Step 2, the component then combines the embeddings from the different models into a single embedding using a specified combination method. Metrics. Metric 1, similarity, the similarity of the combined embedding to the individual embeddings from each model. Metric 2, accuracy, the accuracy of the embedding in downstream tasks, such as classification or retrieval. Visualization plots. Visualization plot 1, scatter plot of the individual embeddings in a low-dimensional space to visualize the relationship between the embeddings. Visualization plot 2, heat map of the similarity scores between the combined embedding and the individual embeddings from each model. Fine-tune parameters. Parameter 1, combination method, the method used to combine the embeddings from the different models. Common options include averaging, concatenation, and weighted averaging. Parameter 2, weighing scheme, if using weighted averaging, the weights assigned to each embedding model. Uncertainty methods. Uncertainty method 1, ensemble uncertainty, calculate the variance of the embeddings from the different models. Uncertainty method 2, dropout uncertainty, use dropout to introduce noise into the embedding models and calculate the variance of the embeddings. Challenges and fixes. Challenge 1, overfitting to the combination method, choosing a combination method that is too specific to the training data can lead to overfitting and poor performance on unseen data. Sample use case that resulted in challenge 1, using a weighted averaging scheme that heavily favors one particular embedding model, resulting in poor performance on data where that model performs poorly. Fixes to challenge 1, use a more general combination method, such as averaging or concatenation, or use a less biased weighing scheme. Challenge 2, choosing the right embedding models, selecting the right embedding models for the task at hand is crucial. Using models that are not well suited for the task can lead to poor performance. Sample use case that resulted in challenge 2, using a language model-based embedding model for a task that requires understanding of numerical data, which can lead to inaccurate results. Fixes to challenge 2, carefully choose embedding models that are appropriate for the task, taking into account the type of data and the desired outcome.